In this video I'll be showing you this metric clock that I built. This is a project that I've been working on and off for about a year now. And the special thing about it is that you can see the numbers go from 1 to 10 instead of 1 to 12. So with the metric time system, there are 10 hours in one day, 100 minutes in 1 hour, and 100 seconds in 1 minute. What that means is that there are 100,000 seconds every day, which is slightly more than the 86,400 seconds in a day in the current system. So this means that each second lasts a bit longer. And you can see here, in this case, every 4 clicks is a single metric second, and it lasts for just a bit longer than a normal second. So this specific one, ignore all the aesthetics and looks. You can see there are quite a few marks from gluing and wires hanging everywhere. This is just a test for functionality, so if I am to make a second version in the future, I would improve how it looks. But the main driving thing is this stepper motor. It has 400 steps, and since each minute or each rotation of the second hand is 100 seconds, there are 4 steps per second. That's why the hand clicks 4 times every metric second. So this stepper motor is connected to, if you could see, black part here, which goes through the center and out on top. And this is the second hand. Then it's difficult to see, but on top of that black part there is this gear that goes to this other much bigger one over here, this one. This gear has 100 teeth and that gear has 10 teeth, which means there's a 10-to-1 reduction from the center to the side. Then in there, on top of that, there's another gear with 10 teeth, and then this gear, which is connected to the minute hand over here, has 100 teeth. That means there's another 10-to-1 reduction. So overall, between the second hand and the minute hand, there is a total of 100-to-1 reduction, since there are 100 seconds in 1 minute. And then between the minute hand and the hour hand, there is a 5-to-1 reduction, then a 2-to-1 reduction. In total, this is a reduction of 10-to-1, since there are 10 hours in a day. So for every revolution of the hour hand, there are 10 revolutions of the minute hand. The top is made with 1 centimeter thick transparent acrylic, and these numbers are engraved with a laser engraver, and the shape is cut with a laser cutter. The same with the bottom here, and then they are connected with 6mm acrylic rods. This circuit board contains 2 main parts. There is the Arduino that sets the timing using the quartz module on it, and this sends the signal to this section here with the 8 MOSFETs. Since the stepper motor has 4 inputs, and each one needs to be able to pull to 5 volts or ground, there are 2 MOSFETs for each input, meaning there are 8 MOSFETs in total. This is basically a custom-built stepper driver that takes a pulse as an input from the Arduino and can turn the stepper motor. So I designed all of these, I designed the physical model on Fusion 360 and designed the PCB on KiCad, and I did this with a friend over a period of a year. So this is the metric clock that I built. Hope you enjoyed.